All right, let's go over the turtle crossing activity. So we are going to be, so this is really looking at some time distance graphs, which we covered in chapter 3, but it's going to help kind of set us up for the work we're going to be doing in chapter 4. So this first one says, draw a time distance graph to represent a turtle's journey across the sand, then press play. So I'm going to do something a little wacky, okay? And I'm going to press play, and it's going to show me where the turtle goes. So we can see, so there's the time that's running along the x-axis, and then the distance, which is along the y-axis. The distance along the y-axis is kind of going up and then down, and then up and then down, and then up and down. So we can see how the turtle gets further away and then back closer to the water, and then further away from the water, and then closer to the water, and then further, and then closer, and then further. And there's also a couple moments there where there are two turtles. Let's try and pause it where those two turtles show up. 3 turtles actually. And we can see, so this gray line shows us kind of like where we're traveling along the x-axis. So at this point, which is at like 5.5 seconds, a little over 5.5 seconds, there's several different places where this graph is. And that's why multiple turtles show up. So if I did something a little simpler, just a straight line, it's just going to show me the turtle. Let's start it over. It's just going to show me the turtle going further and further and further away from the water at a constant speed. There's no multiple turtles or anything like that. Then let's try, what if I did a circle? Not a very good circle, but a circle nonetheless. Aha, so there's 2, because there's 2 different places that the graph shows up. Yeah, interesting. Okay, let's keep going. Aha, so Luca drew this graph to represent a new turtle. So what story does this graph tell us? So I know these like straight pieces right there and there are going to be the turtle again walking away from the water at a constant speed. So the turtle walks away from the water at a constant speed. And then this flat piece, the horizontal piece, the distance isn't moving at all. The distance is staying constant. So from 2 seconds until 4 seconds, the turtle stays in the same place. Then the turtle keeps walking away from the water at a constant speed, and then somewhere around 8.5 seconds, he stops walking. Go on, I think it shows us. Let's press play. So he walks away, and then he stops. And then he walks away again. He goes a little faster that time around, but then he stops. And that's it. So here's Luca's graph. Use the graph to answer the following questions. What is the turtle's distance from the water at 8 seconds? And then when is the turtle's distance from the water 4 feet? So the turtle's distance from the water at 8 seconds would be, we go down to our x-axis, and then follow that up until that 8 meets our graph, which is right around there, which looks like it's going to be 10 feet. 10 feet from the water. And then when is the turtle's distance from the water? 4 feet. So on the y-axis is the distance at 4 feet. We're at time 5 seconds. 5 seconds. Okay. So this is a little funny. You might think, the turtle's walking and then the turtle walks around in a circle and then continues on. But think back to that first, the first level, and I put in a circle graph. What happened? The turtle split into 2, and kind of one was walking toward the water, so the distance was getting smaller, and then the other turtle was walking away from the water. So they kind of went away and then they came back together. And that's what I think is going to happen here. So this story, this graph shows a turtle being in 2 places at once. Let's go on and see the video. So he's walking away, and then splits into 2. They both walk away from each other, and then they start walking back toward each other and merge back into 1 and continue going. So not very realistic, but interesting nonetheless. All right, so we're watching this turtle try and make it past these snakes without getting hit. Classic Frogger scenario. And now, let's try and watch it again. So he goes, walks away, stops, then moves back toward the water, and then walks away. So now let's try and draw this graph. I wasn't counting the time, which would have been helpful, but I know he walks away, and then stops, and then moves back, and then walks away. Let's give it a try. Nope, I would have gotten hit by the snake. Okay. So let's try and do this now. Where we're starting up here. And I want him to get closer and closer to the water. So I think he's gonna need to wait. Is that snake moving this way or that way? Moving that way very slowly. So when does that snake get out of the way? He gets out of the way like now. So right after 8 seconds. So do you think I can get out ahead of him before he passes? Could if he went really, really fast. Let's try that. Okay, let's see. Nope, he got hit by that snake. So he needs to go like super fast. Let's clear that out. Let's see what happens. Aha! So Let's try again. Is he gonna, if I go super fast? I think if I just go super fast, he'll be able to make it to the water without getting hit. Let's try again. Play. Yep, there you go. There's probably other ways to do it too, but that seemed like the easiest way to go about it for me. Okay, let's look at the turtle's distance from the water at 3 seconds. Again, time is on the x-axis. Time is 1, 2, 3 seconds. The turtle's distance is right there, which is halfway between 4 and 8, which is 6 feet. When is the turtle's distance from the water? 4 feet. So it would be here, which is 2 seconds. Whoops. There. Here, which is 5 seconds. There, which is 7 seconds. And that's it. And that's that.